Imagine you were on a walk somewhere and you took this really nice picture with your low-resolution camera cell phone. So it's a cheap cell phone, not the fancy ones we have now. When you come home, you want to display this picture on your big, nice 4K TV screen because it's a really nice picture and you'd like to brag about it to your family. Now the problem is that because you had a low-resolution cell phone, you basically have a small image that you're trying to fit to a large TV screen. And that's going to produce a blurry image like that one. Image super resolution is about taking a small image and making it larger without losing much of the detail. Neural networks could be seen as a computer that performs mathematical operations on an input and then given that produce an output. Now neural networks have been really, really good at visual tasks like classification. So in a task like that, you'd basically feed an input image to your neural network, and then the computer would perform operation on this image and produce the label cat. Now this high performance in classification was not obtained from magic. Actually, neural networks had to go through what is called a training phase. And during training, we're going to feed a bunch of images to that neural network. And with each image that we give, we're going to give the corresponding label. For example, we'd say, well, hey, here's an image, that's a cat, and here's another image, that's a dog. And after seeing all those images, the neural network will be able to understand what makes a dog, and what makes a cat, without ever us actually defining what it is. And if you think about it, that's very similar to the way we humans work. When we're kids, we kind of constantly ask our parents, what is this and what is that? So our parents would tell us, well, that's a cat and that's a dog. And after just seeing a couple of examples, we can say with pretty high accuracy what's a cat and what's a dog. The question we ask today is how can we reframe this neural network problem for a task such as super resolution instead of image classification? Well, in our case, instead of going from an image to a label, we're going to ask the neural network to start with a small image and produce a bunch of operations on that small image, and then produce a large image. And we're going to ask the neural network that it preserves as much content as possible in the small image. We compare here the results of using a basic method of making an image larger with a neural network method, and you can see that we have much better detail than before. The image is less blurry. Now, if you pay particular attention to that image, you see that the texture is a little smooth. In a way, the image looks slightly unrealistic, and you could tell that a computer generated it. And that's bad, because when we show our image on our big TV screen, we don't want anyone to know that a computer has generated. We want it to look real. And we can make it look real with the use of generative adversarial networks. Generative adversarial networks are just like simple neural networks, but it differs in the training phase. Instead of having just one network that's going to output the large image during training, we're also going to bring in the second network, the expert network. And the expert network will be able to tell when the image looks realistic and when it doesn't. And it's going to communicate with the network that generates it. So if the network generates an image that looks odd, the expert network will provide this information to the generating network, such that in the end we get a better image. Here we compare two results. The one on the left is the one obtained with a basic neural network without this whole expert network feedback communication going on. And the second image is the one obtained with generative adversarial networks, when you have this whole communication. And if you pay particular attention to the region in red, you can see how much better the texture is. Also, if you look at the image, the flowers in the background, you can actually see the flowers compared with the neural network, the basic neural network method, where the flowers are smoothed out. Now, the good news is that generative adversarial networks, and actually neural networks as a whole, don't have to be used just for image super resolution. They can be used for many different image-to-image tasks. For example, you could start with a black and white image, and you could ask a neural network to colorize it. That would be nice, for example, if you wanted to colorize the black and white picture of your grandparents' weddings. You could do that with your neural network. The great news is that there actually exists in engineering a lot of input-output problems. And sometimes those input-output problems have a relationship that's very difficult to define. And we can use neural networks to be trained to define those relationships. So neural networks are not only great tools for image processing people like me or computer scientists, they can be used by many scientists of various fields. Thank you for your attention.